I'm starving.
Fifteen minutes later. A little longer than a few minutes later. Much later. $2,000 later.
What's wrong with you, Ashley? I want the omelet so bad, but every time I go there, there's a lot of people in the line. I see. I don't know what time should I go there that I can get the omelet as fast as I can. We can use calculus.
In order to solve Ashley's problems, we have to understand the concept of antiderivative first. When a function f is the antiderivative of f of an interval between a and b, it means that f prime of x equals to fx for all x in the interval a and b. And the representation of antiderivative means that if f is an antiderivative of f on the interval between a and b, then g is the antiderivative of f on the interval a and b, if and only if g is the only form that g of x equals to f of x plus c for all x in interval between a and b, where c is a constant. And when solving a differential equation of the form dy over dx equals to f of x, it's convenient to write it in the equivalent differential form that dy equals to f of x times dx. The operation of finding all solutions of this equation is called antidifferentiation and is denoted by an integral sign. So, the general solution is denoted by this, where this part is called the integrand, and dx is the variable of integration. And f of x is the antiderivative of f of x. And c is the constant of integration. After knowing what is differentiation, we're going to try to find the area under the curve. The random sum of a function f for a partition of a and b with an interval is written as this, where x is the width of the subintervals and c is any point in the subinterval. And if f is defined on a closed interval of a and b, and the limit of random sums over partition delta exists, then f is said to be integrable on the interval between a and b, and the limit is denoted by, which is a definite integral. So, the definite integral represents the area of the region bounded by the graph of f and the x-axis from x equals to a to x equals to b. And now, we're going to approximate a definite integral using the trapezoidal rule. The area of one trapezoid is equals to this, which implies that the sum of the areas of the n trapezoid is this, which is the trapezoidal rule. Now, according to Ashley, we know that she was checking the number of people in the line in the first hour after the dining hall has opened. We know that the interval is 0 to 60 minutes. T is the time that she was checking the people, and f of t is the number of the people. Now, we're going to use the trapezoidal rule to find the total number of people in the 60 minutes. Because the width of each sub-intervals doesn't equal to each other, so we have to find the area of the trapezoid separately. And now, we find that the total number of people in the 60 minutes equals to 450. And then, we're going to times the definite integral by 1/60. Now, this means that the average number of people in the 60 minutes, which is 7.5, because we're calculating the number of people, so we will say that as 8. Now we know that whenever the number of people in the line is smaller than 8, it is the most efficient time for Ashley to be in the line and wait for the omelet.
A lot of boring math later.
I think I understand what you mean. I try next time.
The next day.
Math is so useful.